In the next few videos, we're going to be looking at different types of reactions in organic chemistry. I find it easier to look at organic chemistry by reaction type, as it minimises the number of things you have to memorise because there's lots of patterns you can see. The first one we're going to look at is addition reactions, and this definition here is really important. So look at it carefully and commit it to memory. Once you've read the definition, have a look at the picture and make sure the picture matches the definition. See the carbon-to-carbon double bond on the left, and on the right it has broken and two new atoms or groups of atoms are added, in this case an X and a Y. Note also that the molecule has gone from unsaturated with a double bond to saturated with each carbon having 4 single bonds. In level 2 and 3 chemistry, there's only 4 types of addition reaction that you need to know. The first is adding a hydrogen halide, where X can be chlorine, bromine, iodine, or fluorine. The second is adding a halogen, so most commonly Br2 or Cl2. Neither of these need catalysts. The third is hydrogenation, adding hydrogen with a platinum, palladium, or nickel catalyst. And the last is adding water with an acid catalyst. Dilute acid is another way of looking at this. Here is an example of all of the types of reaction drawn up in a reaction scheme. Remember that we're always starting with a carbon-to-carbon double bond, or an alkene, which is unsaturated. The reaction scheme is getting drawn now, with all 4 types of reaction being shown. Have a look at the products and we'll go through how we can identify each reaction and what the reagent was that was added to the original alkene to make the product. So going from the carbon-to-carbon double bond to the top left product, we've added 2 hydrogens here, so H2. Down the bottom here, we've added an H and a Cl to those 2 double bonded carbons. Up the top, 2 Br atoms. And down here, an H and an OH, or water. Try and focus on the same mechanism, breaking that carbon-to-carbon double bond and adding something to each previously double bonded carbon. Lastly, we need to look at Markovnikov's rule. Markovnikov's rule is how we figure out the major and minor products when we make 2 products in one addition reaction. So here's an example of an addition reaction that makes 2 products. Propene, and if we add HCl, we form 1 chloropropane or 2 chloropropane. In what situations do we actually form 2 products from one reaction? Well, there are 2 requirements that you need to form 2 products, and the first is having an asymmetrical alkene. Looking at the double bonded carbons in propene, one of them has 2 hydrogens and the other 1 hydrogen and a carbon chain. That makes this alkene asymmetrical. So that's one of our conditions met. However, if you think about it, if we add 2 hydrogens to those 2 double bonded carbons, it doesn't matter which carbon we put them on. It's going to make the same product, i.e. propane. So the other requirement is that we have an asymmetrical reagent. HCl is asymmetrical because H and Cl are different. H2O is another asymmetrical reagent because H and OH are different. So those are our 2 requirements, an asymmetrical alkene, and an asymmetrical reagent. The next thing we need to do is to be able to identify which of the 2 products is our major and which is our minor product. And to do that, we need to decide which of the double bonded carbons started off being richer, i.e. having more hydrogens. In this case, looking at carbon 1, it has 2 hydrogens, and carbon 2 has 1 hydrogen. So carbon 1 is our richer carbon. So in this product, carbon 1, which started off richer with more hydrogens, gained another hydrogen. So this must be our major product. And in the other product, it was carbon 2, our poorer carbon, which got the extra hydrogen from the HCl. So this is our minor product. That wraps up our addition reactions. which are all about adding things to a double bond. In the next video, most likely, you'll look at elimination. And elimination and addition are really useful to study together. See you then.